Hello, I introduce myself. Today's title, I talk about a developing renderer. My name is Toru Matsuoka. I joined this company my last September, and my best field is computer graphics. And I've worked in CAD/CAM and VFX, which is creating movies and and computer game industry. I worked in. Today, I talk about developing a renderer, a 3D graphics render. I developing a CAD renderer. My renderer, and CAD renderer is a 3D graphics renderer. It is a ray tracer, and it's developing for over than 10 years. I started this renderer when I was a university student, and so it is written in C++, and this code to so sorry, and this code base is 100,000 line, over the 1,000 line. It's too large. It's grown. This code base is grown too large, and so currently I don't prepare GUI tools for this renderer. This contains only some command line programs. And these images are rendered by CAD renderer. I said CAD render is a ray tracer. All 3D renders are roughly classified in two types, rasterizer and ray tracers. And rasterizer, as you know, so rasterizer image in renders image in real time, and some algorithms included in painter's algorithms, scanline, Z-buffer, and rays. And maybe you know OpenGL and DirectX, like hardware APIs, is included in the rasterizers. And rasterizers are using in to create computer games or real-time visualization. And otherwise, ray tracer is renders a realistic image than rasterizers, and there is a simple ray tracing algorithm and some global illumination algorithm, including, for example, path tracer and bidirectional path tracer, or photon mapping, or some etc. And ray tracers are used by to create movies, like on cinema. Yeah. Rasterizer is roughly said. I said explain this algorithm. triangle project and triangle into the screen. This algorithm, the advantage of this algorithm is last side image so quickly faster than ray tracer algorithm, and usually that buffer algorithm in easy to implement by GPU. So OpenGL and DirectX like hardware API is implemented in implementing gbuffer algorithms. This advantage is cannot render so realistic image like global illumination. So and it can render only triangle polygon meshes. Ray tracer is cast straight into the scene like this, and this algorithm advantage of this algorithm is so render global image or render synthesize realistic images, and so and render various types of shapes. It can render. This advantage is also use memory much than rastrizers because ray tracer is storage all over scene information into memory. It use memory too large, and so rendering speed is slower than rastrizers. And my render's features, my CAD render is a lot of features. This is a list, and CAD render is implementing a ray tracer-based algorithms. So it can render various types of shapes, primitives, polygon mesh, parametric surface, curves, points, subdivision surface, blobs, CSG primitives, and some type of acceleration structures have, and cameras, lot of camera we can use on this render. So CAD render can render various types of shapes like this, and this bike is consists of polygons and cylinders and spheres, some variety of shapes including, and this photo render nerves. So CAD render is included is implemented in to use to render a lot of types of shapes. CAD render is also render surface and curves, and so CAD render can render parametric surface and curves directly. Direct means some typical render, other render convert surface and curves into polygons. before rendering. Converting a smooth surface to polygon mesh is to use a large amount of memory, and so converting polygon mesh it causes another problem. If you move camera in near closer to object, and you see cracks name of polygons. Color render implemented in a lot of acceleration structures. Acceleration structure is a very important component for ray tracers, because an acceleration structure can accelerate speed to compute hit points. Already, color render has implemented some acceleration structure, and we can choose one of them. Each acceleration structure has advantage and disadvantage. But I think in typical render typical scenes, we choose BVH structures. It's good at. This figure left from left side to right side. Most left side figure shows BVH, bounding volume hierarchy, and next is KD tree, and next is oak tree. Into the scene, it's called quad tree. And most right side is a uniform grid. Why need acceleration structure? Typical scenes contains a lot of objects, and for example, we assume the scene contains n objects and need to cast m rays to rendering with a honestly not smart methods. That order is order mn, and using another acceleration structure, this case using BVH, its calculation order might be or m log n. And so acceleration structure can reduce calculation cost so much. What is global illumination? I said Kaz render is a ray tracer. So ray tracer and path tracer and or something global illumination algorithms can render global illumination scenes. For example, this photo shows this area, this wall of side is not so not red, not red. In really white, but it's colorized red because rays from light source bounce left side of red walls falls into this area. Go to it. And so this effect called color bleeding, and in the real world, light rays behavior is complex, and this photo shows make caustics. Caustics means so. Seeing Wikipedia, acoustics is envelope of the light rays reflect or refracted by a curved surface on an object, or the projection of the light envelope of rays on another surface. Rays going through transparency like glasses make a pattern on another surface. And Kazaa Renderer is currently implementing global illumination algorithms, path tracer, and photon mapping. So shading is colorized object light behavior from light behavior, and like this. And so in Kazaa Renderer, we can change shader to shader means colorizing shading style. We can change for example, this upper side is realistic, but below side is cell shading, like cell shading. Kazaa Renderer is including a shading system, and I developed a shading compiler and a shading interpreter using shader printer interpreter using Lua, like this. And Kazaa Renderer wrote some scenes from RIB files. RIB files is a defined Renderman spec document. Renderman is developing a render, developing a Pixar, but Renderman's old specification document is open and for public. Future plan of Kazaa Renderer. I want to rewrite Kazaa Renderer. So because current code base is too large for maintain by myself as a person, too large, and I want to add another modern global illumination algorithms like multiple important sampling, progress photon mapping, and metabolic light transport, etc. And currently, I don't prepare some GUI tools on GCC tools, okay, because I almost artists use renderer from GCC tools. I want to develop an interface plugin for some GCC tools, Maya or Max or something GCC tools. Finish. My talk is done. Finish. Do you have any question? Nothing.
The picture of the cup.
Cup.
Yeah. Is that Cos renderer? Back. The glass and the ray lights. That.
This.
No.
This.
The cup with the water. Glass with the water.
Yes.
That.
This. Yes.
You made that's a picture that's made by Cos renderer.
No. Not synthesized image. It's from Wikipedia.
Oh.
Realistic image. But some. Yes. So sorry. But Cos render can render like this.
So
Yeah, can render.
the computers are getting faster. How long until you can use a ray tracer for real time?
So sorry.
So you mentioned rasterizers are not as accurate. So when they do in movies, they use ray tracers.
Yes. Usually, movie production, creating movie production uses a ray tracer, like so.
So how long until we can have real time animation with a ray tracer?
With ray tracer, all over one movie,
No, for like a video game.
video game, I don't know. Using ray tracer.
Yeah. Is it getting closer? Never.
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 I think never.
Wow.
Because current modern real-time renderer is can generate realistic image for normal 普通の人、end users.
Okay.
I think. Nothing. Okay. Thanks for listening.